Alright, so we're talking about matter. And matter, quick definition, is anything that has mass and takes up space. Or another word for taking up space is, does it have volume? So those two categories, or those two things make something matter. And matter can be classified in a couple of different ways, and one of those ways is a substance. And a substance is something that always has a fixed composition. So if you look on the right here, we've got water. And water is something that always has 2 hydrogen and 1 oxygen. And if you change that, you actually no longer have water. So if you added another atom of oxygen, which is the big red one, by the way, I always think of this as like Mickey Mouse. You got the 2 ears that are hydrogen ears, and then you've got the O for the face, or sorry, this red circle for the face of that's oxygen. Anyway, if you added another oxygen, it would actually become hydrogen peroxide. And there's a kind of a corny joke about that I'm sure I'll tell you at some point. But basically, you don't want to drink hydrogen peroxide because it can kill you, but you can drink water safely. Unless you drink too much, and then that's called drowning. Anyway, bad joke. But moving on. Salt is the same way, right? We have 1 sodium, 1 chlorine. And that's the ratio, and that's always true for salt. If you change that ratio up, then you get something different. So a substance is pretty finicky. You can't change how it's made up, or it becomes something else. So if we look at this, these splints here, these wooden splints, it's kind of shifting gears a little bit, but how would you describe that? And I'm going to switch here. What are all the things we could list if I was trying to describe this as thoroughly as possible? Well, maybe one of the first things that comes to your mind is we could talk about its shape. Oops. Okay. Maybe we could also talk about its size, which is similar. Maybe its mass. Maybe even being more specific than shape, or size, we could say length. And then I'm going to get rid of size. So kind of with length, similar to that would be like its width. Right? These are all ways that we could describe it. We could also even go further, and we could talk about its hardness. Right? You can know that you're dealing with wood as opposed to cardboard by doing its hardness or its firmness. We could even look at its density. We could look at its, I'm blanking here, melting point. Surprisingly enough, that would be one. Does it melt? Does it turn from a solid to a liquid? We could even talk about, does it burn, right? We might find that when we try to determine its melting point, that it actually burns. So wood, we know, burns. And we could actually also describe, let me bump that down a little bit. We could actually also say, well, it doesn't react with air. So, doesn't react with air. That's another way of describing this. So what we've just done is we came up with a pretty thorough way of describing all of these. And you might notice that I wrote them in 2 different columns because everything we say falls into one of 2 categories. Either it's something called a physical property or a chemical property. And the difference between them is that we jump back here, a physical property is something that we can observe without changing what it is. So remember I said a substance always has the same composition, the same thing that it's made up of. So if it's a physical property, we can see that without changing it into something else. So I can see the width of wood, I can measure that without changing it from wood into something else. Same with mass and length. Right? So these would all be what we call physical, and even those at the bottom, right? Hardness, density, melting point. I can observe all of those things without changing it into something else. But the other column here, other group, is different because if I observe that wood does indeed burn, what happens is that it actually changes into something else. Burnt wood behaves very differently than non-burnt wood, right? You wouldn't want to make your house of that because it's much more brittle. It won't hold up like unburnt wood would. And so to observe a chemical property, it changes into something else. So a chemical property, let's see if I have a definition here, is basically talking about really does it react. So does it have the ability to combine with something else and change into something else? So rusting would be an example of that. And so all of these things I listed over here fall into one of these two categories. But with physical properties, they can actually even be further classified. These things here, if you think about them, they're all dependent upon how much stuff I have. So like the length of a wooden splint, that matters based upon whether it's a complete splint or maybe it's one that's broken off and so this part is missing, right? That would change that. That would also change the mass. It wouldn't change the width, right? But maybe I trim off a little piece here as well, and that changes the width. So all of these are what we call, and these things in blue are called extensive properties. And then all of these here in, let's go purple because that's fun. These are all called intensive. Okay, and intensive are things that, how I remember it, are in the I for independent, which means they don't rely upon something else. So these are independent of the amount of stuff, the amount of matter. Oh, I can't write over that. Let's move that up here. Okay, they're independent of the amount of matter. Okay, but extensive depend upon how much stuff is there. Okay, now let's make sure I give you a good list. So physical properties, other ones I didn't mention really would be its taste is actually a physical property. That one's a little tricky, but you could taste something without turning, like you could put your mouth on a piece of wood and it doesn't change into something else. A boiling point and melting point, those are two that are confusing. Oftentimes students get those mixed up. But if you think about water, if you take water that's liquid and you boil it, does it change into something else? Well, it changes into gas or into vapor, but it actually still, if you were to look at it on a microscopic scale, you'd still see that when it's a gas, it still is two hydrogen and one oxygen. So it actually didn't change what it's made up of. Like you could take all of that water vapor and you could condense it again and drink it and you'd just be drinking water. And the same is true with melting. Ice and water are the exact same thing chemically, so melting them is actually not a chemical change, or not dealing with chemical properties. Okay? And so the important thing to remember is that each substance has its own unique set of physical and chemical properties. And so wood has these wooden splints, right? Their shape, their width, their mass, their length, their hardness, their density, their melting point, the fact that they burn, that's unique from like water, right? Water won't have the same hardness or density or melting point or boiling point, or won't react the same way with fire as wood does. Okay? So we can use these properties then to help us identify something that we don't know. So if I find something, and like this is how people could figure out whether they had real gold or fool's gold, they could see the properties, and if it had a certain density, where meaning it wouldn't float, okay, then that was one of the ways they knew that it was really legit gold. It wasn't made up, or it wasn't fool's gold. So there's the application of that.